नमस्कार विद्यार्थी मित्रांनो. डेरिव्हेटिव्ह ऑफ कॉम्पोजिट फंक्शनची उदाहरणं तुम्ही नक्कीच एन्जॉय करत असाल. मागच्या 3 व्हिडिओमध्ये मी पूर्ण इंग्रजीमध्ये बोललो आणि आज मराठीतून बोलल्यामुळे थोडंसं आश्चर्य वाटत असेल. पण आपल्यातली बरेचसे विद्यार्थी हे आजूबाजूच्या ग्रामीण भागामधून आलेले असतात आणि त्याच्यामध्ये अजूनही भीती वाटते की इंग्रजीमधून किंवा मराठीमधून. पण सुरुवात मराठीतून केली आणि बोलत बोलत इंग्रजीत शिरलं की मात्र त्यांना अजिबात भीती वाटत नाही. हे माझ्या नेहमीच्या लेक्चरचा क्ल्यू मी आज सहज जाता तुम्हाला सांगितलं. डेरिव्हेटिव्ह ऑफ कॉम्पोजिट फंक्शन तुम्ही एन्जॉय करतानाच मला मी जे नेहमीच विद्यार्थ्यांना सांगतो की आज तुम्हाला सांगतोय, माझे जे प्राध्यापक होते प्रोफेसर शंकर गौडा, त्यांनी सांगितलेली गोष्ट मुद्दाम आठवते. डेरिव्हेटिव्ह जर एखाद्याला परफेक्ट शिकायचं असेल तर काही गोष्टींची काळजी किंवा काही गोष्टीमध्ये मास्टरी त्याने मिळवायला पाहिजे. कुठल्या कुठल्या गोष्टी? तर पहिलं जे 11 फॉर्म्युले आपण सुरुवातीला बघितले होते, डेरिव्हेटिव्ह ऑफ स्टँडर्ड फंक्शन्स, हे पाठच पाहिजेत. तुम्हाला रात्री झोपेतून विचारलं उठवून तरी तुम्हाला ते सांगता आले पाहिजेत. ही पहिली गोष्ट. दुसरी, 11वीला आपण 4 फॉर्म्युले शिकलेत. डेरिव्हेटिव्ह ऑफ सम, डिफरन्स, प्रोडक्ट आणि कोशंट, अल्जेब्रा ऑफ डेरिव्हेटिव्ह म्हणून. ते कसे वापरायचे हे प्रत्येकाला जमलं पाहिजे, त्याची ट्रिक कळाली पाहिजे. आणि या 2 गोष्टी तुम्हाला जमल्या की मग पुढचा टप्पा आहे. यासाठी एक व्हिडिओ आपण ऑलरेडी याच्या आधी केलेला होता, तो तुम्ही बघू शकता पुन्हा जर कोणाला काही अडचण वाटत असेल. पुढचा भाग येतो, यावर्षी काही फॉर्म्युले आपण बघणार आहोत. ते फॉर्म्युल्याचे मेथड्स पण आहेत, पण मध्ये सगळ्यात महत्त्वाचा टप्पा आहे तो डेरिव्हेटिव्ह ऑफ कॉम्पोजिट फंक्शनचा. आधीचे फॉर्म्युले, अल्जेब्रा ऑफ डेरिव्हेटिव्हचे 4 फॉर्म्युले, डेरिव्हेटिव्ह ऑफ कॉम्पोजिट फंक्शन ज्याला परफेक्ट जमतं त्याला डेरिव्हेटिव्हचं प्रत्येक एक्झाम्पल हे सहजपणे सुटलंच पाहिजे. हे माझ्या सरांनी सांगितलं होतं, मी ते अनुभवलं आणि इतकी वर्ष मीही माझ्या विद्यार्थ्यांना सांगतो आणि माझे विद्यार्थी सुद्धा अनुभवतात. आणि याचमुळं माझ्या कॉलेजचे, आपल्या कॉलेजचे बरेचसे विद्यार्थी हे बोर्डाला पैकीच्या पैकी मार्क मिळवणारे नेहमी बघायला मिळतात. चला तर आज आपण पुढच्या काही उदाहरणांच्याकडे जाऊयात. काही शंका ज्या आल्या होत्या त्या शंकांचे निरसन आज करू. ती उदाहरणं आज या ठिकाणी डिस्कस करूया.
So, in the last session we have seen solutions of few examples on derivative of composite function. So today we'll go for few more examples, particularly some difficult examples or from doubts received from the students. So we'll go for the first example. Find dy by dx if y is equal to, this is a root of cos x plus a root of cos of root x. So we'll go for the solution. We'll consider the given function y is equal to root of cos x plus a root of cos of x. Now no doubt this is composite, but till we have some combination there. This is the combination of addition of 2 functions. This is composite. This is composite of composite function. So question arises, to which part or which method we have to apply. So few students may go directly differentiating, but I will, if you have a doubt, you have difficulty, I will suggest to consider the first part as a u and second part as a v, and to solve these two separately and then to combine using the formula in 11th standard. Dy by dx is equal to du by dx plus dv. So now we consider the first part. The first part, u is equal to, it is the root of cos x. Now I will put the bracket here for cos x because this is inner function. So differentiate it with respect to x. Now root is outer function and cos x is the inner function. Already we have seen few examples of this type. So we go for the next step, du by dx is equal to derivative of outer function. Root is 1 upon 2 root of bracket into the derivative of bracket. Derivative of root is 1 upon 2. And inside the bracket we have cos x right in both the places. And so we know that derivative of cos x is minus sin x and divided by 2 root cos x. This is du by dx, derivative of the first part. I will call this as equation number 4. So, okay. Now we'll go for derivative of the second part. Consider v is equal to a root of cos of a root of x. Here it is composite of composite function. But here still we'll consider the square root as outer function and cos of root x as inner function. Only two forms. It is f of g of x. So differentiate with respect to x. We get dv by dx is equal to, now derivative of root is 1 upon 2 root of bracket into dy dx of bracket, and bracket is cos of root x. I'll write that here. Now no change in this part. This is 2 into the root of cos of root x into over the derivative of cos of root x. Now this is the inner function. Okay. So over the derivative of cos x, this is minus sine of bracket into dy dx of bracket. Notice bracket, it is a root of x here. So, okay. So now bring this minus sign outside. It is equal to minus sine of root x is divided by 2 into cos of root x into, go for a derivative of root x. This is 1 upon 2 into root x. So finally we are going to get the answer. It is minus sine root x upon cos root x. It will be tan root x. I'll write back into numerator. Tan of root x. Here we got dv by dx is equal to minus tan of root x upon 4 root x. Already we have obtained the answer for du by dx is equal to minus sin x divided by 2 cos of root x. So already we got both the answers, du by dx and dv by dx here. And see, previously we have considered y is equal to u plus v, so dy by dx is du by dx plus dv by dx, and you are asked to find dy by dx. So you use this 4 and 5 in 3, using 4 and 5 in 3. So see what we are getting. dy by dx. This is du by dx is minus sin x is divided by 2 into the root of cos x plus dv by dx is, this is minus tan of root x divided by 4 root x. And friends, this is the answer for dy by dx. Here, so just we have split this into 2 parts as u plus v, where you use the formula for derivative of sum equal to sum of derivatives. We have separated the first part. This composite, already we have solved few examples of this type. We have used the formula for derivative of composite function here. This is composite of composite function again. See, 2 times you have to use the formula. And then we have combined both the derivatives to find dy by dx. Clear? Any doubt? find dy by dx if y is equal to e raised to log of, inside the bracket we have log of x bracket square minus log of x square bracket complete. Okay, so we'll see how to solve this example. So we move to the solution. Now consider the given function. I'll write it again. Y is equal to e raised to log of log x bracket square minus log of x square. I will put one more bracket here. I will call this as first. Now if we may consider this as e raised to one term, this is composite, and again inside the log this bracket, and then inside this bracket we have the difference, here bracket square, and here it is inside the log we have x square. So maybe combination of composite function. But if you are remembering one property of simplification or property of logarithm, that logarithm and exponential functions are inverse functions of each other, and so we use that. We know that e raised to log of m is equal to e, and log are inverse operations of each other, so they cancel each other and we are getting that as m. Now we will make use of this. E raised to log of this is m. So now it will reduce to y is equal to log of x bracket square minus log of x square. So this is the simplified form of the given function. I will call this as 2. Let you may differentiate it directly if you are getting, or consider the first function as first part as u, second part as v. I will call this as 3. Then, by the formula you have studied in 11th standard, derivative of difference equal to difference of derivative. So we are getting dy by dx is equal to du by dx minus dv by dx. So simply we calculate these two separately. Now consider the first part, u is equal to log of x bracket square. Now students, we can see this is the composite function, because on x we have to operate log first and then we have to take its square. So there are two operations. Now what is the outer function? It is bracket square, and inner function is log x. So we'll differentiate. Differentiate with respect to x. So we get it as du by dx is equal. If we are remembering the formula form, y is equal to f of g of x, dy by dx is f dash of g of x into g dash of x. So we make use of that. This is bracket u, g of x. It's a square, so you get it as 2 into bracket raised to 1 into dy dx of this bracket. And inside the bracket we have log x. So this is 2 log x into derivative of log x is 1 upon x. That is, we are getting du by dx as 2 log x divided by x. I will call this as next equation number 5. So this is the derivative of the first part log of x bracket square. Now we'll move to the second part, log of x star. Now construct. V is equal to log of x square. Student, is it necessary to solve this formula by composite function? If you are solving, no doubt, you will get the same answer. But if we are remembering the property of logarithm, we can simplify this to a simple function or standard form. So that log of m raised to n is n into log m. So this may be written as 2 into log of x. So this is the one way we can differentiate it. So we are getting dv by dx is equal to 2 is constant, taken outside the derivative of log x is 1 upon x. So we got directly the value of dv by dx. Okay. So if somebody does this derivative of log of x square by composite, then also we are getting the same. The derivative of log of bracket is 1 upon bracket, so it will be 1 upon x square there into, you have to go for derivative of x square, it will be 2x. Now x will get cancelled, we are getting the same answer. Okay. So this is dv by dx, second part. Now we'll combine this du by dx and dv by dx in 4 using this 5 and 6 in 4. So we have dy by dx is equal to du by dx minus dv by dx. Du by dx is 2 log x upon x, and minus dv by dx is 2 by x, or you may take 2 by x common here. We are getting this as log of x minus 1. This is dy by dx. Okay, so this is the method of solving. Now the answer is very simple compared to the given question. But student must remember that in case of MCQ, we can further go for some simplified steps, or we can add a few more steps. One can be written as this is 2 by x, and we are getting this as log x minus 1 is log of e, and so this answer may be written as 2 by x into log of x divided by e. So in MCQ, the correct answer may be given like this instead of this, or it may be given like this, log of x by e bracket is 2 by x. So if you are asked to find dy by dx in descriptive question, you can stop up to this only. But you must know more steps of simplification for MCQ question.
So I hope you have enjoyed the solutions of today's example. And just as I have talked in the starting, if you are familiar with the algebra of derivative, the derivative formula for derivative of sum, difference, product, quotient, the derivatives of standard function, and if we got the clear idea of the derivative of composite function, then you can solve any example very easily. That's it for today's session. If you like it, click on the like. If till you are not shared to your friends, definitely you can share. If you are not subscribed to the channel, subscribe it. Thank you very much. Goodbye.